Okay, this is Paul, and today I have a antique GE fan on my bench here at Electro Restore, and the customer brought it in, said it's running slow, needs some adjusting, definitely needs some grease, and here's some information about it. See if you can see this. Get the light down there. It says type AOU and form is AE2. The number of this unit is F112082. Specification number 27214R-1. It looks like 148-1. And it's catalog number 75423. General Electric Company, of course. 110 volts, 60 cycles, so it kind of dates it. A 20s fan. It's got a nice brass GE logo sconce and brass blades with brass rivets. We're gonna take a look at this unit. Right now I got it on my Variac so I can bring it up slow and show you what it's doing. It's currently off. Let me turn the unit on here. And we'll give it about 110 volts since that's what it's rated for. I've already powered it up once, so I know it'll take 110 volts. On high, I'm going to check out the coil here, but on high, it goes at that speed, which is really almost dead. You know, when I turn the speed down to medium, rather, it picks up. So we might have a bad coil. We'll let medium get up to speed, and then I'll show you low. Okay, that's low. It seems to be faster than medium. So it could be that the speed switch is wired backwards. I noticed somebody put a newest line coil with a ground plug. It's a Longwell cord. It's pretty much like what you would use on a computer or disk drive or monitor cord, but it is grounded and is black, so it works. But we're going to troubleshoot the switch and clean out the unit and get it running up to par. So I'm going to mount my camera overhead and then I'll be right back. Okay, we're continuing on this fan and taking out the front oiler. We'll take a look at that. And you can see here that it is full of grease and gunk. That is absolutely horrendous. So we need to clean out the front and back oiler and put in new wicks. Clean as I go here. Okay. So yes, these will need to be cleaned. See if we can get the back one off. you know, they should only have oil in them, not grease. And there's the other one. You can probably see how nasty that is. Again, gunk. Not oil, it's grease. So those will have to be cleaned out thoroughly and redone. And I'm sure we'll have to disassemble the gearbox and see about cleaning that all out. Get some of the dirt off here, off the motor gearbox, so when we get in there we don't get dirt, grease everywhere. Okay. And I'll clean it off after we get going, but it's getting the worst of it off. We don't want to get much of that in the fan while we're working on it. So we'll start by disassembling it, especially the base, and take a look at the coil and see what's going on there. I think it's just wired in reverse when it's with the line cord on. They just got it backwards or something. Okay, that's better. It's actually in really good condition. At some point somebody had sprayed, I don't know if they painted it with a brush or spray painted it. They might have painted it with a brush. I'm seeing what looks like brush strokes. But that's okay. I mean, that preserved it. You can probably see the smooth here, a little rust underneath. So, yeah, that should have preserved it. I'm going to go ahead and take the front end off so we can see it better. Now which is just the motor. And I'm going to loosen that some more so it's not engaged. And we'll see what kind of torque this motor has. Plug it back in. Let's put it back on off. It's got no real power at all. Try a higher speed. That's a little better. We could have an issue with the coil on the bottom. That's strong there. Okay. So we'll check the coil. Backup power off over there. Okay, I'm going to go ahead and set these out of the way so they don't get grease all over everything like they're already doing. A bit of alcohol. Okay. And since we're going to be working on just the coil at this time, I don't really think we need to worry about anything dripping here, so I'm gonna take this out of here and set it right on my bench, which is carpeted. Okay, let's see. Okay, the screws are at the bottom. And this one, some GEs, they put those little screws, 3 little screws on the top coming down. This one has them from the bottom going up, and they're flathead screws, which is interesting. Somebody put some nice felt on the bottom of this, which is nice, because that keeps it from sliding around on your furniture or scratching anything like shelves or cabinets of furniture that you may set it on. It's always good to have a nice support underneath. This one has not been on here long. Okay. Well, they did a good job with that. They refelted it, and they put this ring back in and bent the tabs back over here and here and here. Looks like 4 or 5 tabs there. So that's good. They could have cleaned that a little bit, but that's all right. They did clean the bottom. It's pretty clean. And there's the coil. And the contacts seem to be okay. We might clean them up a little bit so that it makes a little better connection on these. That's first speed is here, so that should be high, but they've got that wired to low. So we'll have to pull the speed board out and find out why that's the case. Okay, we got the control out of the fan, and there's a few things here that I sure don't I don't particularly like, but it is what it is. What they did is they, on the head wire, they used some black electrical tape and a crimping connector, and they crimped the daylights out of it, but wire is, the cloth wire is deteriorating here, and it's almost completely exposed. Here they put electrical tape, and you can see it's just coming unraveled, and they got it grounded to the housing here. If that wire, which you see there, is now bare, I touch that, fireworks for sure. So we're going to take that off, and we'll clean that up, fix that up. But right now I want to just wanted you to see what was going on. Let me get the light shining on that a little better so you can see it. And you ought to be able to see that pretty well. Get my wrench here, and we'll unhook that wire. I think it's a little bigger than that. Let's try this one. That looks like it. Okay, let's take that off. And the cloth's just deteriorated there, and just probably the old wire was on there. Well, they used the fork and they opened it up and forced it in there on that bolt. There's a lock washer. I'm just going to go ahead and put that back in there. Put the washer back on there just to make contacts on that coil. It's possible that part of the coil has seen some damage. Look at that. Oh, maybe not. Oh, what do we got here? power hot in. Let me get a wrench and take that off. I apologize for the noise in the background. It's kind of cold today, and so I got my heater going. Okay, let's set the motor aside over here, out of the way. We'll come back to him a little later on. And we'll move this over here and we'll check out this coil. Now, that's off. So we know that that's supposed to be high. And I can see that that crimp on that coil wire is not doing too great there. Let's see if we can close that up a little bit without loosening it up, if there's such a word. Yeah, it's a little better. So that's high, which is where the line cord should have been, not here, because when it had the line cord here, it was going through the entire coil to get there, which would be low. Medium was medium, because it's the center tap of this coil. Actually, show you how that looks for those of you who may not be familiar with how this works. You have the plug, right? And originally it was just a two-prong plug. It could go in either way. It was not polarized. They didn't have polarized plugs when they made this. So you had a line that came in, and it went to this sweep arm. So we could put a sweep arm here. And then the other line came in and goes right to the motor. So here's the motor. When I say the motor, I'm talking about the head wire that goes up to the top. It goes directly to the motor. The other side of the motor comes down, and on this one, let's see how they had that. Okay, it came down and it connected to this terminal back here. The power coming in connected to the sweep arm here. And the fork they had over here. So you got a sweep arm, and I'm going to make that a little bit longer so you can see it better. And it goes to the off position. Now this is reverse. It would be this way. No, that's the way it goes, like that. So we're looking at it upside down like this to see the contacts and the sweep arm. But the off on this one is down here, because flip it over, it's up there, and that's what we're looking at, is these contacts. So we have three contacts. We have one here, one here, and one here. Now this one, where they had this going to, they had it coming over here and going to this fork, to this terminal. So you could think of this as high, medium, and low, because that's the way it is on the bottom. High, medium, low. They had this connected here. That's wrong. That doesn't connect there. That connects up here to the high side. And then here you have a coil that comes out, which is basically a resistor coil, and it comes to the low side. And so when you move and this does if I can find my other diagram, it makes it a little clearer. Yeah, this one is high, medium, low, which is different than most. Most of them are low, medium, high. Okay. So off. So yeah, this would go directly to the motor. When it's, and then this coil would come up here and connect to this high pin too. Now when it's on, when you move this down, and you move the lever, this would connect to the high. So I'll just put a dash line. When that goes to high, basically you're putting this wire directly on the other side of the motor, so that the outlet, the power line is right across the motor. So the motor runs in full speed, just like it was plugged directly in the wall and didn't have a switch at all. When you move it down further, and this wiper blade, I'll put another dash line, comes to medium, then what happens is the line current comes in through here, goes through this, doesn't go this way because there's nothing there, it's nothing connected to it. Goes through this side of the coil, which is half of the coil. So whatever the coil resistance is, let's say for instance that this is 500 ohms and this is 250 ohms. It'll go, and so this would be 250 ohms here. The whole thing would be 500 ohms. So it would go through 250 ohms of resistance, say, which would cut the current down, and that would be the medium, and then it would go directly to the motor through that connection, which would be this wire here. Actually, it's upside down. It'd be this wire here. So that wire on high doesn't do anything, it just energizes the coil. On medium, it would go through the coil and come back to here. And this is where the fork would be that goes up to the motor wire. Okay, does that make sense? All right. Now, so that would be here, medium. That's high, that would be medium. When you move this to low, and you put it this way and see it, when you move this to low, you're again moving this switch down further, the wiper, and now it's coming down to that terminal. Now the current is going through two parts of the coil. It's going through a part of the coil here, which is dropping the voltage down some, and it goes through this part of the coil, which drops it down some more. So you're dropping the current down twice, or the voltage down twice, which drops the current across the motor. So now you're on low. So the current has to take this path to get to the motor, because this is wrong. This is not connected. This is how they had it, and it was definitely wrong. It needs to be on the other end. So basically all we got to do there is put the wire they had here, we need to put it there, and that's the end of that problem. I don't know why they didn't see that, why they didn't do that. You would think when they took the old wire off, they would have seen it was connected there. But anyway, we will put it back there. So now, let's see if what I'm telling you is correct. If we go to resistance, and if we got this on off, which would be over here, and we're going to look at it from this side so that it matches the diagram and makes sense, and you should be able to see that meter. If I put these together, it goes to zero, basically to 0 ohms. So we're saying that the one connection should be here. So if we take our hot wire, because that's high, and we put it on that terminal there, then when we move this wiper here, we should be at 0 ohms, and we are. There's a little bit of resistance through the brass wire, but it's pretty much 0 ohms. I can't make a good connection. There you go, point 0.1. So it's basically 0 ohms. So that's high. Now when we go up to medium, you notice the resistance goes up to, okay, it's looking like 5 ohms, 4.9. So that puts a resistor in line, which lowers the voltage and therefore lowers the current, and the fan turns slower, and that's medium. So this is full speed, no resistance. This is medium, about 5 ohms of resistance, 5.5 ohms, and this is low. And you'll notice the resistance is almost, well, it's higher. Let me get a better connection on that brass. It needs to be cleaned. Not getting a very good connection on there. See if I can get it from the bottom here. Okay, so you see it's 8 ohms. So 5 would slow it down some. 8, obviously, slow it down a lot more. So this is low, this is medium, this is high. They had it just the reverse. Now by going through this demonstration, what I have done is just check this coil to make sure that the coil is working. Because now I know that across the coil, this is off, across the coil to the medium, the center tap of the coil, I have 5 ohms. Actually 4.9. When I go across the entire coil from one end to the other, I have about 8 ohms. So I just tested the coil. I just verified that the coil is fine. There's nothing wrong with the speed control, even though it's an antique speed control. We just checked it out. What we do know is it needs to be cleaned. It needs to be cleaned 2 ways because it's got dirt on it, but also it's got oxidation on this wiper that goes across these. You can see that just some of the brass is shiny, very little, and on low, none of it's shiny. So that's why when we had it on high, they had it wired backwards. They had to wire over here, and it wasn't making very good contact. And so it was going through the entire roughly 8 to 10 ohms of resistance. Actually, the impedance is higher than what you're seeing with just an ohm meter because it's AC, and the coil resists the flow of AC. So the impedance of the coil is higher than the actual DC resistance that the meter registers. But it wasn't making good contact, so I was able to just stop the motor from turning because it wasn't getting hardly any voltage through these connections. When we clean this up, that's going to help that a lot. The second thing, of course, that'll help that a tremendous amount is when we re-grease the motor and re-oil it, fix those oilers, and then this motor will be working in good shape. So there's no sense in me showing you how I clean all this. If I run into anything out of the ordinary, I'll do that. But basically, I'm going to clean the metal case. It's actually not metal, it's an insulator. It's composite material, some kind of plastic, but it's very heavy. Well, this is metal here. This is an iron core for the coil, so that adds a lot of weight. But I'm going to go ahead and clean this with just some solvent, just clean it. The fixtures I'll take off and I'll use emery cloth and just clean them up a little bit, and then put them back on. Clean them with some contact cleaner too to make sure they make good electrical contact. Same thing here on the top. You don't want to wear these down, so you don't want to be in here sanding this unless you know what you're doing. But with emery cloth, I'm just basically going to take that tarnish off the top of the brass, and I'll show you that once I get it done, and clean the wiper blade here so that it makes good contact. It's actually not the wiper blade. It's not this part of the wiper. This is just a selector switch. The wiper blade is inside there, which you can probably see. I'm trying to keep everything under the camera, but I can't see what you're seeing. There's an insulator here. Let me If you see that round thing, looks like a bean or like a bean. Actually, it's just a round turret, like a barrel-shaped turret. That rolls and stops, rolls over these peaks and drops in these notches. And so that's when it rolls over this, it snaps down in between and it shorts out to high. Well, that's what it's supposed to do, connects to high. Then it goes over the second one, and the wiper, which is this part of it here, is what hits these. That wiper needs to be cleaned too. It's copper. You can see the edge of it here. It's copper, and it's oxidized. So the brass bolts are oxidized, and the copper is oxidized, and so the connections are not that great. They impose resistance. That's why I was having a hard time getting an ohm reading on them. But I'll clean that up, and then we'll work on the motor assembly. But let me go ahead and get that clean, and then we will continue the video from that point. Okay, I figured I would stop and show you this part of the process of what I'm doing. When they put this one together, they put this over the sweeper arm to hold it down. And you can't tell it here because I unscrewed them anyway, but basically they cut the screws and then they smashed one in, and they did that just so people wouldn't be taking them apart and get afraid to take it apart or whatever. But anyway, it was more so to make room and make sure that those screw that went to the screw didn't short anything or anything like that. But since I had it apart and I'm getting ready to clean it, I wanted to show it to you. You can see the dirt on that bottom of that sweeper arm. That's never been cleaned because nobody's ever taken it apart. Here's that little bowel thing I was talking about. Yeah. You see that? It's just a little brass bowel on a cotter pin that turns. That's what rides over this rail and drops into different places. So, and this is the contact. This is the part that actually makes contact. You see, it's kind of shiny, so it's doing okay. It's got a little flat wear spot because it's been used, but we're going to clean that up a little bit too with some contact cleaner. So I figured while I'm at this point, I could turn the video back on and let you see what I'm doing. Basically, I'm just using 91% isopropyl alcohol. It's a good cleaner. It's a safe cleaner. It won't hurt anything that we're doing, but it does a good job. You see how it takes that right off. Now, on the motor housing, you got to be careful if you use alcohol to clean anything, because it could remove the paint. And well, that's not a big deal. We don't want to deal with that. We don't want to take the paint off, as it wouldn't be pleasing. You see how much gunk is inside of there, in between this selector rod and the actual contact shaft. But I'm going to get the grease out of there. Clean is always more efficient than not clean, so you want to get it clean. And so that's what I did there. I just cleaned that out. Now, the bearing there, we could put a little bit of oil on that. You hear how it's squeaking. So I'm going to put just a little drop of oil on that. And you can use any kind of oil. 3-in-1 oil is fine. I have Zoom spout, but we don't need anything that drastic. This is just a little brass bearing on a cotter pin, so a little spot of that squeaking is gone. And it's turning much more free. And it don't take much, it'll air dry a little bit, but paper towel go in here. Okay, so that takes care of that. We can wipe off a little bit of the excess on the barrel there itself. The barrel does not need any electrical connection. It's not electrical, it's just rolling over these teeth and dropping into place. That's all that does. So this doesn't connect to anything. It's just embedded in this casting. I'll blow that out later with my compressor and get all the dust out of there. But it's just embedded in casting, and it's just to keep this on the contacts and not between two. If that stayed between two, it could hurt the coil. So those just line it up with making sure it's only on one contact. So now we'll clean them a little bit. And I'm just going to use this little piece of emery cloth here. And you want to, if you do this on anything you're working on, you're doing this at your own risk. You got to be very gentle. You do not want to hurt the contact. You just want to get the crud out of it. If you take too much off, this contact may not make good connection. But at the same time, if you don't take some of it off, you already don't have good connection like on this one. So it's best to go in circles and not push. I'm not pushing at all. I'm just lightly rubbing over the tarnish to take the tarnish off. And I'm not even going to get it all off. I'm just going to get the worst of it off there. Because you don't want to deteriorate these brass fittings and connections. But you see how that's making it better. This one has pits. I don't know if you can see them. There's a pit, a couple pits here and one in the center. That's just where the contact was sticking to the shaft when the connection, and not making a good connection, so it's actually sparking there in between, causing those pits. Okay, and that's pretty clean. That's much better than it was. The other thing I want to clean, and very lightly, because this is just copper, is this. And that's just very lightly. Just more trying to get the connection clean. The part that hits the contact is already pretty clean, but you see those dark spots on the sides of them, on the side of that rising spot. Just want to get that junk out of there. Okay. This is just a dry paper towel to get any residue off. Okay, now what I'm going to do is put some deoxide on there, which will get rid of the oxidation and make a nice electrical connection. And this stuff comes in a very little tube, and it's a little pricey, but it does a good job. It's for electrical connections. And just put a little drop on that. Don't take much. And then I got somewhere I got a clean finger. There we go. And just spread that on there a little bit. You see how that eats up the oxidation on that. We're also going to do it on these. That's why I said I wasn't going to do a lot of sanding, because we really don't need to. We just need to get a little of that on there. And that'll clean it up and make very good electrical connections. Okay. Giving away all my trade secrets. Alrighty, that's that. Now, the rest of this is just cleaning. So, you know, this needs to be sanded a little bit, get some of that stuff under there, that rust out of there. And then what I'm going to do is I'm just going to wipe this down with some oil, just to keep it from rusting. You know, keep it clean so it don't rust. The rest of this, the only thing that you notice that's rusting here is these nuts. These, this one's zinc or nickel, so it's not rusting, but these two are just iron, and the heads of the screws have been treated at the factory. They were actually originally painted, these two were. But they're okay. They're in good shape. I might hit them with some black just to clean them up a little bit. Same with that there. Just clean up what I can to keep it from rusting further. And same here. I'll just hit this with some oil. And that'll be it. We'll put it back in the unit and then verify that the fan is turning in the right way. And then we'll work on the motor head and getting the motor working. So, thanks for watching. Okay, you can see here how I clean this up. And clean this up, got a little bit of the rust off of it, top and bottom, did the same thing, put a little oil on it. Clean the contacts, which you've seen me do. Put a little oil on these to keep them from rusting. And the switch is fine now. It's hard for me to do it with one hand, but you get the idea. And on the bottom, I went ahead and hit the screws that were losing their covering so that they won't rust. Hit the nuts that were rusting around here. Cleaned it up pretty well. It's doing good. Notice that it has the date on it for the patent. It has the patent number, and then it has the patent date, which is November 21st, 1911. That probably means that this is a 1912, maybe 1913 fan, because it took them a while to get the patent, and then when the patent was approved, then they had to stop producing these with the patent number on it. So give it a year or so, but it gives you a good idea of the date of the fan, somewhere around 1912, 1913, 1914. Pretty good. Anyway, I'm going to go ahead and wire this back in, clean up the wires, and then we'll do a test run. Okay, what I did is I got rid of that metal mini clamp and put a real cord restraint cord on it, thing on there. The fork that was on there I replaced with a loop so it'll make a better contact like the one that was there. I went ahead and taped this head wire up temporarily and put some stuff on there so we can at least connect it back up and test it. I'm out of cloth wire, so I'll have to order some cloth wire to rerun a new head wire. This one's in pretty bad shape. As you can see there, it's just falling apart. And this tape they put on there is that's just not going to get it. So we need to get a good cloth wire on there. I'm also going to check with the customer and see if he wants me to get a cloth wire and change this cord out, put a more appropriate cord on here. I can still use a ground plug, but and this one's fine. It's up to the customer if he wants a cloth wire on there with a grounded plug, or I would definitely put a grounded plug. This cord's fine. But we definitely need a new head wire. So check into that. But right now, at least I can put the switch back in and continue working on the fan while I order the part I need, the cords I need. All right, I got the base back on. I got the speed control in, and the motor is now working correctly as far as speeds. That's high. Still needs to be greased, but that's high. That's medium. And that's low. So we fixed the speed control by just switching the wires around and cleaning it up. And it's got more torque than it had before. It's a little harder for me to turn, but it's still, you can tell by the noise, it still needs help. It's saying, help me, help me, help me. So So we will help him. We will make him purr. Okay, we're back to the inside of the unit, and actually this one, while the grease is mostly gone, it was packed. The grease disintegrated, it lost its viscosity, but it's more like oil than grease. But you see how it also is drying up. Okay, here. Look at that. Actually, it's not too bad. It just needs to be cleaned out and repacked. But you can see there's some dry spots in here. Maybe they just didn't clean it out. Look at this. They might not have cleaned it out when they, see how dry that is? When they repacked it, they might have just gave it a once over and left some of the original grease in there. But it's not really too bad. It needed more grease. Probably should have been cleaned out really well and then greased. Okay, getting ready to reassemble this, and I wanted you to see, cleaned it all out, nice and clean. And there, see how clean that is? Got all of the old grease out of there. Even has a number on the bottom, which I can't quite make out, but part number down there, which is the manufacturer of the unit. Here's the gear. It had a lot of old dry grease caked in these teeth, but I got probably 95% of it out of there. Cleaned the worm drive. And this gear here, same thing. It was caked with stuff, but I got that pretty clean. So again, nice and clean. I could clean it a little more, but there really isn't any sense in it. The chunks of dry grease are gone. There's just a little bit of staining left in there, but that's normal. Gonna clean this guy and then start reassembling it. I'll put some grease in there when I assemble the bottom half, and then show you what that looks like. Yeah. I'm gonna have to get outside and get some air for a minute or two. These chemicals are pretty strong that I use. We'll be back.